Welcome to our podcast, where we explore fascinating stories and ideas from various fields. In this episode, we explore how NASA's Spitzer spots a giant space debris cloud. NASA's Spitzer Space Telescope has spotted a star-sized debris cloud from a distant collision. The research, published in the Astrophysical Journal, discusses in detail the major smash-ups between rocky bodies that shaped our solar system. In the study, a group of astronomers led by Kate Su, a research professor at the University of Arizona Steward Observatory, reported the first observations of a debris cloud from one of these collisions as it passed in front of its star and briefly blocked the starlight. They call this a transit. Coupled with knowledge about the size and brightness of the star, this allowed researchers to directly determine the size of the cloud shortly after impact, estimate the size of the objects that collided, and watch the speed with which the cloud dispersed. Beginning in 2015, Su's team started making routine observations of a 10-million-year-old star called HD 166191. Around this time in a star's life, dust left over from its formation has clumped together to form rocky bodies called planetesimals. Asteroids are leftover planetesimals from the formation of our solar system. Around other stars, they are the seeds of future planets. Once the gas that previously filled the space between those objects has dispersed, catastrophic collisions become common. Anticipating they might see evidence of one of these collisions around HD 166191, the team conducted more than 100 observations of the system with Spitzer. While the objects would be too small and distant to resolve by telescope, their smash-ups produce large amounts of dust. Spitzer detected infrared light, wavelengths slightly longer than what human eyes can see. It's an ideal range for detecting dust, including the debris created by protoplanet collisions. For the first time, we captured both the infrared glow of the dust and the haziness that dust introduces when the cloud passes in front of the star, said astronomer Everett Schlawin of the University of Arizona's Steward Observatory. Multi-wavelength transit data confirm that the transits were caused by a dust cloud passing in front of the star and evolving at a fast pace as it grew wider and more opaque during the first two transits, but showed very little hint of the cloud afterward. These data allowed the team to determine the location, shape, and size of the debris cloud. The team's work suggests the cloud was highly elongated, with a minimum estimated area of 3 times that of the star. However, the amount of infrared brightening Spitzer saw suggests only a small portion of the cloud passed in front of the star, and that the total amount of debris created by this violent event covered an area hundreds of times that of the star. There is no substitute for being an eyewitness to an event, said George Rieker, study co-author and a Regents Professor of Astronomy at the University of Arizona. All the cases reported to date from Spitzer have been unresolved, with only theoretical hypotheses about what the actual event and debris cloud might have looked like. By looking at dusty debris disks around young stars, we can essentially look back in time and see the processes that may have shaped our own solar system, Su said. Learning about the outcome of collisions in these systems, we may also get a better idea of how frequently rocky planets form around other stars. The team is continuing to keep an eye on the star with other NASA infrared facilities, including the Stratospheric Observatory for Infrared Astronomy and the Infrared Telescope Facility. Such observations not only keep a record of overall infrared flux evolution, but also provide additional information on the dust composition of the freshly generated fine dust with spectroscopy. Particularly, future observations with the mid-infrared instrument on board NASA's James Webb Space Telescope will provide further insights into the physical condition of these large collisions by studying dust mineralogy. Thanks for tuning into this incredible story. If this episode resonated with you, don't forget to hit the like and subscribe button for more captivating stories to come. Stay tuned.